Let's go over chapter 3, the things that we have done. This is your time to get involved. Okay. So what do we talk about in chapter 3? Instance variable and encapsulation. Talk to me. What do you know about instance variable? What do you know about encapsulation? Should I call your names, or how do we do this?
Instance variables should be private.
Okay, why is it private?
So the class itself is the only one who can access to it, and nobody else can affect the data inside.
Okay, I like the question, but I'm looking for something more than that. Who can give me something more than that? What are the instance variables of an object? Come on, guys. Remember, the option of not talking is having quiz every Friday. So I don't have to drag you guys. Please talk, please talk.
What was the question?
I'm going to give you a quiz and do it. That way I don't have to worry about it. The question is, what is the instance variable and encapsulation? You guys making me cry.
Well, an instance variable is like variables within like an object.
Okay.
And then
why do we have it? How do you figure it out?
Well, because like variables within like main, right? The public main function is way different from like simple variables such as like ints, strings, doubles within another object.
Yeah, we are not going to go there. We are not talking about main. Let's just stay with our class and let's focus on instance variables. I'm looking for a keyword for the instance variable. What is the instance variable to my object? Remember, we had a picture in the book about the backpacking to go to hiking. It's the things that I need to keep track of. So the things that I need to keep track of, the elements that I need to keep track of, those are my instance variables. So if I'm going to the hiking, what is it that I need to take with me? So that's what my instance variables are. So what is encapsulation?
It is the idea of bundling data, methods, and instance variables together to get a comprehensible object.
I like the way you're reading stuff. Let's put it in our own word. We talked about this on Tuesday.
Yeah, it has to do with the just kind of focusing on the big picture, right? Not getting too caught up with the like every single detail of how it's implemented.
No, I don't like your answers so far. I need a better answer. Jose, you should know this.
It's basically the plumbing to implement the class without having it in the main program.
No.
It's the black box analogy.
Okay, what is the black box analogy?
Just not being too concerned with every single detail and how it's implemented.
I don't even know the detail. So it's going to be information hiding. It's going to be detail hiding. You got to know this one. They're going to ask you this in your interview. You got to know this. You fail this one, you're not going to get a job. I'm telling you right now. So you better be sure that you know what you're doing. Okay, so the next one, go ahead.
Never mind. No.
No, go ahead.
No, I was just going to ask something, but you said it, so it's okay.
All right. So what about our public interface of a class? What is the public interface of a class?
is what the outside code can have access to the class, like methods that they can use of this class.
Okay, I don't want this session to be about 2-3 students and I need everybody get involved. I need you guys think. I need you talk. That's the best way to know how much you don't know. So talk, and I try my best. You guys help me to create a safe environment for everybody to talk. So that was a good answer. Manuel, are you here or are you sleeping?
I'm here.
Okay, what do you think about the public interface?
It's the part of the class that you can access from other classes. So anything that is marked public, these are usually methods and not instance variables.
Okay, so how do I know what methods do I need for my classes?
Well, you typically want accessors and mutators.
Okay, so how do I know what? Okay.
So if there's a variable that and constructors.
No, go ahead.
If there's a variable that you don't want the user to access directly, you can have them modify it through a mutator or access it through an accessor.
Okay, so to go a little beyond that, is the action that my class is going to be doing is going to be defined in our methods, in our public interface that you write. We're going to do that. So it's going to be your constructor, it's going to be your mutator, it's going to be your accessors, and any other methods that I need. So what is my class is supposed to do? So if I have a class, what is this class supposed to do? How do we comment our public interfaces? Yelling Leo. Yelling Leo.
Here.
Hello?
What's the question?
Were you sleeping?
No, I'm just taking notes.
Taking note of what? The question is, what is the commenting public interface?
Sorry, I don't know.
What? Okay, so we have one vote for the quiz next week.
It's a steps 1 through 6, right?
No, comment.
So basically /**, and then you
Yeah.
write what it does, and
Yeah.
then you either include parameters or the return type.
Yeah. So
No quiz.
no quiz for you, but they still have to give it to you. So every time we're writing code, we're going to have some comments. We talked about this. So we have 3 levels of comments. The package level, we haven't got to that yet. The class level and the method level. So the question is, do we have to put all the comments into Javadoc? First of all, what are the comments for Javadoc? Jose was talking about it. I need somebody else to talk about it. Jiaxi Yang.
Yes.
What are the Javadoc? How do you do Javadoc? And why don't you have your camera on?
Because my cat is around me right now.
What?
My
I
cat.
want to see your cat. What the hell? I'm pretty sure we all want to see your cat.
For the comment into the Javadoc, I think
one day I'm gonna sit down and write all these excuses in a book. The excuses that my students gave me.
You gonna publish
I
it,
want
or
to create a book and maybe I sell it for
try to monetize
seller
it?
and make some money. The excuses I hear from my students. All right, go ahead. I'm sorry.
I can't sure. It's kind of is it the Javadoc? Is the how to 3.1 is the one you want us to do for the program design?
So what again?
I can't sure. Is it the one you want us to do the program design that the how to 3.1 question? No.
Did you read your chapter?
Yeah.
Oh, you didn't. So you're voting for the quiz for next week. So this is number 2.
How are the quizzes?
These are going to be the questions. Instead of me forcing you guys to answer it, I'm going to put it in a quiz. The people who know, they're going to get the point. The people who don't know, they're going to get a 0 for it.
Right.
So the same thing, I rather to do it through conversation. But if you guys don't want to do it through conversation, I'm going to create quizzes just like this. I'm just going to give it to you, and individually you're going to answer this. For those who answer it, fine. The person who don't answer it, then they get a 0. We're moving on. Jia Yang Cho. Jia Yang Cho. Jia Yang Cho. Okay, that's number 3. Hector Ramirez.
Here.
No, you're here. Thank you for being here. What are the Javadoc? How do you create it? How do you write comments for Javadoc in your program?
Are you asking about the actual lines we use to write them?
No, the comments.
Oh, then we do /* and depending on and as for the actual comments, for a void class, we don't put a return. We just put any actual, like, what's it called? I want to say method.
Forward the / star is for Javadoc. So when we do that, we're going to have 3 lines. The first one is for what?
The first one is for the purpose, the second one is for the method, and the third one is for return.
Description. Then the next 2 lines is going to be your parameters or your return. Generally, you don't have both of them, either or. Okay.
Professor, I have
Yes.
a question.
Yes.
So what's the difference between like /* and just /*? Like I see no difference except the format.
Right. So when we do the forward the /, let me be sure that I understand your question correctly. So let me bring this one over here. So are you asking what's the difference between forward / star versus forward / which both of them going to be finishing with a star forward /.
Yeah.
Is that your question?
Yes.
Okay. So even though it gives me a lot of pain, I'm trying to relax. So the first one is a regular comment. The second one is for creating Javadoc. This is good because I have my Zoom on. So in case I get a heart attack or something, you guys can see it. You guys putting so much pressure on me. You should know this by now. Okay. So that's the question on number 5. Do we have to put every comments that we have in our program into the Javadoc? What's the purpose of Javadoc? Who's going to be looking at Javadoc and who's going to be looking at my regular comments? And are they the same thing or they can be different?
So your fellow programmers will look at the Javadoc who is doing the same project with you.
Right. So general purpose of Javadoc is what? To give a description, a return value, the parameter. Of course, there are some other ones like author and those kind of things that you can put it in different places. But not necessarily everything that I have, I'm going to put it in Javadoc. Sometimes I have some comments that's going to be locally in the program that if you come inside the code, you're going to see. But remember, I'm going to be hiding code from everybody else. So the Java code, Javadoc, is something that everybody's going to be looking at. So if they want to use my method, if they want to use my class, what is this class doing? What is this method doing? What parameters do they need? But if you are a developer or myself coming back inside the code, and we're going to go try to fix something, then there's going to be some comments over there that not necessarily general public needs to know. If they need to know, I'm going to put it out there. But we are not going to put too much over there. We're not going to put too little over there. Javadocs, description, return value, and parameters. Any other questions?
I have a question, Professor.
Yes, go ahead.
So if you have for example, you start like a couple lines above, like let's say we already have like a set coding and we're just commenting it. If we have for example the 1-star comment and then a 2-star comment, like starters, like do we require 2 enders or just 1 ender? Because I face this problem in like trying to comment my own code. But like,
okay, say that again. I want to be sure that I understand you correctly. So what you're saying is you can have 1 star like this, and then are you saying that you're going to have 2 star inside the 1 star? Is that what you're saying?
yeah, I don't know the interaction between is that looks like that, because I tried to comment out an entire class using the extended just regular comment, not for Javadoc, and it kind of like it kind of looked really weird and not like how a comment should look like. So I'm asking like, what is the interaction between the two?
Okay, so the Javadoc, you have something that's called Javadoc generator. So the idea of the Javadoc comment is that if I go and press that button, it's going to create web page for people outside of my class to know what my class is doing, what my methods are doing. So if you want to use the method that I have, then you're going to go to that web page and it's going to tell you how to use my method. What is this class about? Now, the other one is just a regular comment. Now, from inside the code, from the compiler concept, if you have 1 star or 2 star, it's basically ignoring. Compiler doesn't look inside of these things. Compiler doesn't care what you have inside of /. As soon as it sees /star, it doesn't look at anything in there till it gets to a star /. So it ignores everything between those two. Now, when I mix them up, I have to be sure that remember, I also have the option of //. So for me to kind of be organized and doing things, I am generally using /** for block of codes and my Javadoc, and the rest of my comments I'll put it in /2 of them, //. That's going to give me a comment from this point to the end. So let's say that I have a local variable. Let's say I have 98.7, and I want to explain what 98.7 is. It doesn't need to go to Javadoc because it's part of my coding. I'm going to use either /* or I'm going to use 2 slashes and explain 98.7 is normal temperature. The Javadoc doesn't need to know this. This is my local comments. Did I answer your question?
Yeah.
Okay. Any other questions? This is good. This is the reason that I want to do this on Fridays. Any other questions? Okay, moving on. What else did we have? So we're going to be providing the class implementation. That's where we're going to be writing code. We talked about the unit testing. What is the unit testing? The people The students who are sleeping in this class. You can
Isolation.
loud.
Isolation.
You can loud.
Yeah.
Are you here?
Yeah, I'm here.
What is the unit testing? You can. No.
I think it's about
Are you reading your text? Somebody's texting you?
no.
Okay. Oh my God, this is depressing. This is the advanced class. You guys are supposed to be advanced. Come on. Man-Ting Tang. What is unit testing?
I think it is the testing and isolation outside the complete program, which is like we should generate a class into a program and you test it outside.
Good. So we're testing our class. So the unit testing, we are testing our class. We are not writing the whole program. We are just testing our class. So if I created a class for my bank account, I'm just going to test that class. I'm not testing the whole bank account application. So that's the unit testing. Did anybody in this class tried out BlueJ? That's a tool that you can use to test. So generally what we do is we're creating a main program, main class that we're going to be creating a new object, testing the methods that we have, testing the constructors that we have to be sure everything is working fine. That is the unit testing that we generally do. But BlueJ has a tool to be able to do those things. Especially if you have a lot of classes that you want to test, you might not want to write main for every single one of them. Anybody used BlueJ to try it out, see how does it look?
We used it in high school, AP Comp Sci class.
Oh, which high school is that?
Arcadia High School.
Oh, good for you guys. What about the local variables? What are the local variables?
It's the variables within the function method itself. So it only exists inside the method or just inside of one brackets.
What's the difference between local variable and instance variable?
So instance variables exist for the entire class. The local variables can it will only exist while the program is running, like the method is using or inside a loop or something.
So if I have a local variable with the same name as my instance variable, which one is going to be used?
So you use this dot, the variable name, we'll call the instance variable. And then more likely it's going to call the local.
I like that. That's good. But the question is, if I have a local variable name and an instance variable name, which one is going to be used?
The local variable.
The local variable is going to overshadow the instance variable. That's why we're going to be using the reference, this reference to differentiate our instance variable with our local variable. There are some people, some developers, that they put the word this in front of every instance variables. In our Python class, and I guess you're coming from Berkeley class, we are using underscore for our instance variable. That is not the convention for C++. That's a convention for Python, that you'll be using underscore for our instance variable. So all of our instance variable are going to have the underscore. That's the way we differentiate the. So if I have a student name, if it has underscore at the beginning in Python, that is an instance variable. If it doesn't, then it's local variable. But that's the convention over there. Okay, doke. What else do we have? All right. So ready? How to 3.1. You guys were supposed to have been doing your design on this. So every program that you write, you have to do the design first, not after you're implementing your code.
And the design document, it just it consists of steps 1 through 4. Because 5 and 6 is like the actual implementation.
Correct. So some of you guys are making me nervous, so I have to figure this out. So what was the step 1 in how to 3.1? Step 1.
Listing the
What is the
method.
first thing you're supposed to do?
Finding the method.
Yeah, which method they're going to be using.
Yeah. Oh, like you asked me which one are we going to be using?
So what again?
Are you asking me like what are we going to be like which method?
No, I'm just saying a step 1.
Oh, okay.
Okay. So what's the step 2? You're going to specify the public interface. So what is it that we need for outsiders to look at our class? What is the step 3?
Document the public
Document
interface.
public interface.
Document it. That means what? We're going to be writing Javadoc comments on top of them. We are still doing this in Microsoft Word or Note or something. It is now, we are not doing these things in our IDE. The reason I'm saying it, because we all have such an urge to start writing code. And if we are not in IDE, we are not writing code, hopefully. We are not writing code yet. What is the step 4?
Determine instant variables.
So if I have some methods, the question is, if I want to do this method, what variables do I need? This is going from bottom up. And we have a different design of going top down. So defining your instance variable somewhere, somehow, in here we are practicing, we're going to go with the methods first, and then we're going to ask the question, what do we need for this method? We're going to create our instance variables. And there is other designs that you would go with instance variable first, then you got to get to your methods, the things that we want to track of. What is number 5?
Implement constructors and methods.
So we're going to be implementing constructor and method. This is the part that we're going to do it in our IDE. So up to page 4, we are doing it in a document. I want to see everybody's design document. And it should not have any coding in it.
You want this design document steps 1 through 4 for every program from now on.
For every program, but remember, every chapter is going to have its own how-to. So we're going to modify it as we go forward.
Okay.
As we go forward, we're going to modify this.
So we're going to add
for now, for this week, every problem that you have, you should have a document 1 through 4. Then you copy your number 4, you put it in your IDE. When you're writing the code, you should not be thinking about anything. You're just like a robot writing code. That's it. You take the comments, you make the code for that comment that you did. If it's not working, that means your comments were not done correctly. That means your design was not done correctly. I should be able to take your document 1 through 4, send it to anywhere in the world, and they would be able to write the program for it. So it has to be that detailed. Do we have number 6?
Testing class.
So you need to do unit testing for your class. So you create a main, you create new objects of your class. So if you have default constructor, who doesn't know what the default constructor is? What is a default constructor?
A constructor with no parameters to construct an object with default parameters, default instance variables, I mean.
Okay, good. So we're going to put the values of default for the instance variable, and then we're going to have a constructor with parameters. Does Java create default values for us? Java is a user-friendly language, so it tries to do as much as possible. So if I don't have any constructors, it's going to set my default constructor. But if I have a constructor with parameters, it's not going to do that. It's going to wait for me to set them. So you should have default constructor and constructor with parameters. Anything else about the things that we did last week, or this week?
You talk about the underscore and like the this, I guess like the similarity between those two symbols or usages.
Okay, again, underscore is coming in from Python. That's where I have seen it as a convention. It's convention. Again, you can do anything you want, anywhere you want, whatever you want to do. But as a convention, when I am doing Python, Java, and C++, when I see underscore, I automatically think of Python because I'm doing that. Now, we have an instance variable. We have a local value. Local variables are going to shadow my instance variables. I have to differentiate them if they have the same name. So a rule of thumb is what? If all my local variable are different name than my instance variable, I don't have to worry about anything. If they have the same name, we have to differentiate them somehow. That's where we're going to be using this reference. This reference is going to be pointing to the current object. So when I say name, that name can be a local variable, including the parameter of my method. When I say this dot name, that's going to refer to the instance variable. So if I have two names in my method, and I'm receiving a name from the user, and I have a name in my instance variable, I cannot say name equal name. So I have to say this dot name equal name. I just stay away from it by to be sure that my local variable don't have the same name as my instance variable. On the other extreme, there are some people that they're using this for every instance variables. So every instance variable they have, they're using this that in their code, this dot is going to identify all the instance variables. That's the way that Python is looking at it. So when you have an underscore, that is automatically your instance variable. That's the way Python does it. So I don't want to go there. I just want to say extreme on one side is to have a this dot for every instance variable that I use anywhere in my class. Extreme on the other side is I'm never ever going to have a name of a local variable the same as my instance variable. The compromising middle is whenever I see a local variable name, I'm going to be sure I'm going to use this reference for my instance variable. Did I answer your question?
Yes.
Good. Any other questions? No questions? Okey-doke. What time is it? 10:25. So we took a little more time than I expected, but that's okay. We are robots writing code. Yeah? Remember, when you are doing the implementation, you're not doing any thinking. Your thinking is going to be on design time. It is not during the implementation. We like to write code. We jump in there, we start writing code. That is not going to work for large project. It will work for a small project, and that's what we're doing right now. But I want you to practice on it. You have to think. If I am looking for a restaurant, I just want to eat hamburger today. I can sit in my car and go around and find a hamburger place. Or I can sit down and think about what kind of a hamburger do I want? What kind of a restaurant do I want to go? Then I can plan for it. Then I can put it in my phone and go direct it out. It's going to take less time. Now, if I take this and make it as a larger project, so instead of the hamburger, I want to go ski, or I want to go hiking, then I need more planning. I cannot just start walking and then say, okay, eventually I'm going to get to the hiking. I cannot start driving and say, eventually I'm going to get to San Francisco. I may get there, but that's the way we are writing code sometimes. We start driving and we are hoping that we're going to get into San Francisco. And that's why we have so much stress at the end of the project. Instead of 5 hours, I don't know how long does it take to go to San Francisco, it's going to take us 2 months to get there because we keep trying different things. We end up in San Diego and somebody says this is a wrong place, you better go the other way. And then eventually we might get to San Francisco, but it takes us a longer time. Think about that. You need to practice on doing design. I don't like to do it. I didn't like to do it. I learned the lesson, how important is it? And that makes a difference between a software engineer and a programmer. Programmer doesn't have to think about all these things. The software engineer is going to design the software, just going to give it to somebody, write it in C++ today, tomorrow write it in Java, next day write it in Python. You don't have to think about anything. Just write the code for me. I'm going to tell you exactly what you want, what I want, and I want you exactly write the code with what I'm telling you to do. So I'm taking the thinking away from you. You're just going to be writing code. You got to decide where you want to be. All right. So we have an activity.
So I had a question.
Hold on a second. We have that. I don't know. We got some activities that we didn't do last time. We still have a section that we need to cover. And somebody asked about the lab. And we have another question. Go ahead.
Yeah, so what's the difference between the software developer and a programmer?
Yeah, that's what I was telling you.
You kind of covered it.
So software development is going to do, software engineer is going to be thinking about, for now, right now, you remember I said about 1, 2, 3, 4, that's the very small right now, we're going to add to it. So you're going to be thinking about the whole software life cycle. Programmer is going to be just doing the last part, implementing. Or is going to be doing just the testing part. So we're going to hire you. All you're going to do day in, day out, you're going to test the final project. So we're going to give you some boundaries. You're going to be testing, reporting what is wrong with this one. Then we can go back and fix it. Or we just give you the design. We're going to give you a template with the comments on it. And we're going to ask you to write the code for it. And today, it might be a Java. Tomorrow, I might need a C++. So I just pick up the people who are good in C++ or Java. Software engineer, understand the whole concept. Even if I end up just writing the program, I understand the process. I understand how these things are coming along. So when I am doing my modification, when I'm writing the code, I have this concern about how the whole thing is connected to each other.
So I had another question. I mean, this is more of like your perspective on it.
Okay.
Do you think the community college curriculum teaches or emphasizes more like the programmer aspect instead of the software engineer, or vice versa? Like, which one do you think is more emphasized in this?
I have my heart is saddened in that area.
Yeah, I think so.
So most of us, if not all of us, we start with writing program. Doesn't matter where you are, what you do.
Yeah, I think
we do not teach.
That's more emphasized.
Yes. If it was up to me, we would have our software engineering course before you start writing code. This was not me before. This is me right now after my experience and all those things. That's one thing. Number two, 3A, 3B, 3C is supposed to focus on object-oriented design. I don't think we as a school doing it. I don't think a lot of places are doing it. That is what it's supposed to be. The reason I chose this book, because this book is going through those processes. But believe me, that I have students who don't want to do it and they go complain to the dean about it. Even though the book is asking for it, even though I am going through it, there are some people who are resistant to doing the design. They think it's a wasteful thing to do. For a small project, it will work. For a bigger project, it's not going to work. But if I am a coder, I don't want to do the design. I just want to write code. And it's not going to work for sending a rover to Mars. It will work for a coffee shop, a store, mom and pop. But even with a coffee shop bigger than the mom and pop, it's not going to work. I cannot sit down and write code for Starbucks coffee. I have to design it. I have to know the structure of it. And worse than that is when we get to the end of the project, if we spend good amount of time in designing it, it's going to be a lot less stress. I'm not saying we're going to take the stress away. It's kind of impossible that we're going to start a project today and we're going to say 3 years, March 31st, we're going to be done with it. It's going to be a few days here and there. Now, the question is, are we going to work like crazy from February through the March because we didn't design it correctly, or are we just going to stay a few days? So when you talk to people and they say that every time we have the end of the project, we cannot sleep, we have to work 6-7 days a week, and it's going to get very hectic. If that's a continuation of things, if you're telling me that every class that you have in your final project, you don't sleep and you work through it for 24 hours, 48 hours straight up, that is not a good design. So you can see that in the hackathon things. They come in, so we're going to have a hackathon for 48 hours. You guys got get together and do this. That is not a software engineer. That's just checking for heroes. Of course, they're checking for some other things in there too. But that is not software engineering. Software engineering is planning. You will take a software engineering course. They're going to emphasize these things for you. My goal is to see the difference at the end of the project. So when I was a project manager, I was asking my employee to do 2 types of design, bottom up and top down. If you would come into my project, you would think that I'm crazy, I'm making you guys work too hard. When you stay with me one project and you see how much of a headache I can save you if we do the design correctly, at the end of the project, you would appreciate that and you would ask to be part of my team from that point on. So that's the difference. You're going to focus on the thinking part before you implement it. But all of us coming from the coding, so we all, and the worst scenario, I got to tell you this. So we're going to talk about this as we're going to be designing. So we go to a room, the customer comes in, and the customer is going to tell us what they want us to write the program for. What is the first thing that we as a programmer do?
We try to code because that's how we've been trained to.
That's
how we've been trained.
So the customer is talking and I'm thinking about the coding. And as soon as I do that, what happens? I stop listening to the customer.
Yeah.
So some of the things that customer is talking about, I don't even listen to it. So how am I supposed to create that at the end of it that even if I didn't listen to what the customer is asking for. So those are the issues with the software engineering versus coding, programming. Yes, you come to me after I design the project. I'm going to tell you about the coding. You just think about the coding as much as you want and you go on and write the code. But that is not everything. That is just the end part of it. So if you look at the software engineering, they're talking about 20, 30% of the time for coding. So that's the programmer side. The new language comes in, the new programmers coming in, but they still, the software engineering is not going to be that. So Google is going to change the language from Java to Swift or something else, or whatever they do. What is Google going to be using these days?
Golang? Is it Golang or something like that?
Goalie or something.
Yeah.
So what's going to happen to all those Java programmers?
They become
They'll
outsourced
find
by other
themselves some other
programmers.
job or do something else.
Yeah.
But the software engineers are still doing the software engineering job. So that's the difference between the programmer versus the software engineer.
Okay, thank you.